Hello, everyone. We are going to start in some minutes, but before we start, I would like to say thank you for joining our webinar. Today we have really interesting topics to discuss. That's why I would like to remind you, please feel free and ask your question in the box under the video. In the end of conversation, our experts will answer you with pleasure. And now let me please introduce our today's host, Willem Tromp, a Dutch researcher with 25 years of experience in project and resource management, MPM and business consultant, a co-founder of Epic Flow and Glow Management, lecturer and speaker. Hello, Willem.
Hello, Anastasia.
And now I give the floor to you to introduce our today's special guest, Mario. Hello, Mario.
Hello.
Thank you, Anastasia. Okay, hello, everybody. Hello, Mario. We already discussed that we have met for the first time in 2011. You almost forgot, as you remember. I was supporting two master students which were defending their thesis with you as being the professor. Since then, I'm following you. I'm reading your articles and also reading some of your books. You're also a professor at the Ghent, or it's called Ghent University in Belgium, and also work for the business schools Vlerik in Belgium, London, Lisbon, and Beijing. Welcome to the webinar. It's great to have you here. And basically, you are the only reason that we're here because you wrote a great book called The Illusion of Control. So welcome, Mario, and I have a very, very simple question. Why did you write your book, and for whom did you write it?
Okay, thank you for the introduction, first of all, Willem. Why did I write my book? Well, first of all, because I think I'm a writer. I love writing books and I love project management. That's what I do. And sometimes I feel that urge to write down my research such that I try to reach a broader audience. So that's the main reason. But your question is, for whom did I write the book? Well, I think I aimed for two different types of audiences. First of all, academics, for sure. Because for those who have read the book, I tell the story of my academic work. I tell the story of my PhD students, what they did, how they suffered, and what their results are. And I wanted to tell that story to academics, to tell them, look, what we do is interesting, is fascinating. And I also wanted to thank my PhD students for that. But a second type of audience is for sure, no doubt, professionals, people in the real world. Because I truly believe that what we do has practical relevance. I'm not saying that all the stuff that we propose in our research papers can be translated tomorrow into tools and techniques. Of course not. But I think I want to walk on that bridge between theory and practice. So a long answer short, I think that I wrote my book for people who are interested in walking on that very fragile bridge between theory, the academic world, and the practical world of taking decisions to deliver projects successfully to their clients.
Okay, excellent. Now, you already know that I also like to walk on that bridge. And you from the academic side, and I'm more from the, let's call it the professional side, which is great. So let's dive a little bit into the book. You start with three important subjects, and then in order to control your projects and be successful, you have to do three things. One is the basic schedule, risk analysis, and earned value management. Can you tell more about that? Because that's the core where you started your book with.
Yeah, okay. Well, I think it's an interesting question because these three components, scheduling, risk, and control, are the foundation of everything that I do, both in my academic career, but also in my consultancy work. It's a long story, but let me try to summarize that story in a few sentences. I did my PhD a long time ago in the development of algorithms to construct a schedule for a project. Most of the time, that's pretty complex. You have a project with resources, and we develop all kinds of fancy algorithms to find the best possible schedule within the limited number of resources. That was my PhD. I loved it a lot. And then I graduated and wanted to become a consultant. I started my own company. I also started to teach to business schools. And maybe a little bit to my surprise at that time, no one was really interested in only scheduling.
Yes.
I understand why. A schedule, a plan is just a plan. It's worthless because no one follows the plan anyway. And so I started to talk to people. Why is planning, why is scheduling not very relevant? And most of the time, what I heard was because things go wrong anyway, Mr. Murphy, you know.
Okay.
And so I thought, okay, risk analysis is maybe more important than planning. Risk analysis is trying to detect if Mr. Murphy comes along, if things go wrong, what is the impact of that risk? And if we better understand that impact, then we are better prepared for uncertainty. And so that's why I added that second component in my research, risk analysis.
Basically, you do this upfront.
Yeah. Well, I do it in the beginning before I start with the project. But of course, while the project is in progress, you can redo such an analysis if you have more information. Yeah. But indeed, upfront. What I learned about risk analysis is that if you run, for example, Monte Carlo simulations, that's one of those techniques, you can't do that if you don't have a plan. And that's why I think that planning is interesting. If it's not interesting on itself, it's interesting to analyze risk.
I have a question about that because my clients are suffering from bad planning, meaning they do not fulfill the requirements for a good plan, a good schedule. I always say you have activities with dependencies, you need resources, and at least you need the amount of work which is needed and perhaps the duration. Is this a small summary, a basic schedule?
I think that's the perfect summary. You need indeed activities, relations, and information for the resources to construct the schedule.
But I see a lot of cases that it's not done. So they are missing the resources and they just have durations. And if you're lucky, they have some connections.
Tell me about it, Jan Willem. I have seen it also. Many companies, many people say, okay, we're not going to construct a feasible plan because it's not relevant anyway. Well, one of the reasons why you should do it is because if you want to have a proper risk analysis, then you need a plan.
You need it, yeah. The funny thing is that I'm an old guy, 64, and we didn't have things like MS Project, so we created a network planning because we didn't have the computers, and somehow this is gone. I still prefer to create a basic schedule based on a network planning, which you create together with your team. But okay, this is my experience. So we were at the moment, you need a good basic schedule in order to do risk analysis, which is quite important because you know Murphy will hit you. Continue, please, Mario.
Yeah, so then we have already scheduling, risk. The third dimension, as you mentioned in your question, is earned value management. I prefer to call it project control because earned value management is just one possible technique to control your project. And project control is a dynamic, meaning that if you are executing your project, then on a regular basis, you at least have to measure whether you are doing good or not. You have to measure cost and so on. You have to see what the status of your project is. And earned value management is one of those techniques to do that. And what I have seen in my research is that if you really want to use earned value management in a proper way, again, you need a plan. Yeah. So that's the second reason why planning is relevant. So if people tell me planning is worthless because you don't follow the plan anyway, then I tell them, I know, but it is very relevant for risk analysis and for project control. And those three components together is the foundation of my research.
Okay. Thank you for that. You also wrote in your book that in the beginning you were not satisfied about the techniques that were used in earned value management, and you enhanced it. Can you elaborate on that? Because I found that very interesting and agreed with it, by the way.
Yeah. Well, that specific thing about earned value is in a way funny. When I started to work on earned value management, that was, by the way, inspired by a consultancy project and not from an academic perspective. Then I saw that you had two classes of professionals. You had believers and non-believers. It was almost like a religion. Some people really believed in earned value management, and not a bad word about this technique because it's the best technique ever created on earth. And then others find it totally crap and only talked about the flaws and the mistakes and the weaknesses of that technique. And it was almost like black and white, those two camps. And that's the reason why I started, first of all, to carry out some research in EVM.
Okay.
My main ambition was not to promote or to destroy EVM. My main ambition was just to test when it works and when it does not. I remember that was a long time ago, but I remember a quote from a professional project manager from the States. Tony Barrett was his name. He's already retired. And he wrote after my research, he wrote, "Thanks to that research, I understand why earned value management works so well for some projects, but why it fails for others." And that was my ambition, was to show why it works and why it fails and on what that depends.
I think this is also the duty of researchers. Huh?
I guess, well, I think that's one of the three duties of research, to try to provide professionals with insights why it works and why it fails.
Yeah.
But in my book, I extended that to other research, main goals of research. If I can elaborate a little bit on that.
No, I was one of my questions, so please continue.
Yeah, so the first one was test whether existing techniques work or fail. Once we understand that, then I think the second main mission of academic research is to improve those techniques, because if they fail for some projects, we have to improve them. Let's say the nice thing about academic research is that if we improve, we can go all kind of different directions. I used a lot statistical project control, where I added a lot of data and a lot of statistical techniques to improve those methods and make them much better. So I think that's a second step of academic research, not only testing, but improving them. I think there is also a third mission of academic research, and that is basically going totally crazy. I give you an example. Everybody those days talks about machine learning, and machine learning consists of a lot of advanced algorithms. Oh, there are so many different complex algorithms. I tested them too, to see, do they work for managing projects? And the answer is yes, they do, but I do not think that the real world is ready for that. I mean, they require so much data and so many complex algorithms that I believe that this part is purely, at least today, for the academic world, not yet for the business. And I think those are the three missions of academic research.
Okay, it's interesting because I'm in the professional world, and everybody is asking us, "What do you have on AI?"
I know.
I always say, "What is your problem? What do you want to solve?" So I will throw some AI to you, and then it's solved. It's basically crazy, of course.
I think it doesn't make sense. And I think, honestly, that AI today is a hype. I'm not saying it's rubbish, but it's a hype and everybody wants it. But not many people really know what it means for them. I mean, AI for me is just a more advanced algorithm with more data, and it does something that the statistics did 10 years ago. But if you don't know what your problem is, then AI will not solve it.
Now, we have some AI components. I will not go into it, which are working, but okay, it's not a subject for today, but very interesting. I want to make a switch to your operation research and scheduling group. I call it your group, but I'm not sure if this is the case. This is from the University of Ghent, correct?
Yes, indeed. I founded that group 25 years ago or so. Nice.
Okay.
Nice.
How many master students and PhD researchers are involved?
Oh, well, yeah, all those master and PhD students are young people, so you know how it goes. They come and they go.
Yeah.
But in total, there were already, I think, maybe 30 or something PhD students. Currently, we have 10 working on those topics. And
okay.
I can tell you, nice people, but 10 is enough to guide them.
Yeah, I can imagine. And this is only on the Ghent University?
Yeah. So the basis of my research is in Ghent. Yeah.
Okay. And what kind of data do you use for your academic research? You wrote in this book about it.
Yeah, I wrote a lot about data. Yeah, I spent the whole part of it, 100 pages or so. Well, we use two classes of data, and it's very important to, first of all, understand the difference between the two classes, but also, I guess, why I use those two classes. The first class is what I called in the book artificial projects. So those are not real projects. It's just projects that we generate here on our computers with advanced generators. And the second class is real projects. Let me first talk about the first class. The main advantage of artificial projects is that we can control everything. Like you mentioned 5 minutes ago, we can control the number of activities. We can control relations between activities. We can control the resources. We have full control over the data. And I think that this is very important for academic research. Because what I don't want is just test algorithms on some case studies and not knowing what it really means for me. What I want is I want to test under what we call a full design, how those methods work and why they fail. So we measure all kind of diverse projects, so many projects that I truly believe that any project that can be out there in the real world is somewhere in our database.
That means that it was a huge effort to create that data.
Yeah, I'm working already on that for 20 years and it's still going on.
And do you share that data with your colleagues, your scholars, let's call it this way?
Yeah, we have a website with a lot of data, more than people want, but every different data set that we created is created for a different purpose. So yeah, we have a lot. Yeah.
Okay, so I can also use that.
Yeah, I can send you the link. I can post a link here somewhere.
Oh, that's great, because if you have companies like our company, we could also check our own algorithms with your data, basically.
Indeed. I think that if you really want to test a new algorithm, you have to test it on created data first.
Okay, created data, let's call it artificial data. You created this with a purpose to be able to test new algorithms, correct?
Yeah. Indeed. Yeah.
And you have different kind of data because you have different situations.
Yeah, indeed. So, for example, if I want to test an algorithm that tries to optimize resources, then of course I focus on data sets where the resources are very important.
Yeah.
But if I want to optimize something else, then I need other data, of course. But it's always a project that I try to generate.
So this is one set of data. You said you have two types of data.
Yeah, so that's artificial data. So under a very controlled design. Now, artificial data has one weakness, and that is if we do research on, for example, project control, then what we really need is real progress of a project, right? Yeah. Where Murphy strikes, risk comes in, things go wrong, these things. Let's call that progress data. And if we use progress data in our research, then of course we can generate it ourselves by adding uncertainty and then try to imitate reality. But here is where real data is much better, because real data is, of course, data where real problems occurred. So you have real durations, real problems, real cost overruns. And of course, at the end of the day, that's what we need to control a project. So the empirical projects are much better for the dynamic progress data, while the artificial projects much better for the static data, so to speak.
Can I use an example from data? What I see in my practice, we plan. Let's just call it a task somewhere in the network of activities. Yeah,
Indeed.
You do your estimation. You have your resources. You have your duration. It always starts. Are the predecessors already done? So can I start on the planned date? Most times not. Then is the resource available on the moment I can start? Also a question. But what I see is that a lot of people do multitasking. So they start a task, do not finish it, and then jump over. Is this the kind of data, that the real data that you want to use?
Among others, yes. Yeah. So,
and of course, the difference between the estimation and actuals, but that's more logical.
Yeah. So if we look at real data, then indeed what we want to see in that real data is what are the reasons that caused the problems and how big the problems were, how many delays, how many cost overruns, things like that, which you can never see in artificial data, of course.
Yeah, okay. So that's now we are building the bridge.
Yeah, indeed. Yeah, but and there is even in my book a whole chapter that
Yeah.
claims that that bridge could be built. We call it calibration procedure. That's quite technical, but just to say that we are working as academics on that bridge between the two to improve the accuracy in both worlds, not only in the academic world, but also in the real world.
Okay, then maybe we should have a talk after the webinar how we can help you with real data, because you have a lot of data. We just have to anonymize it, and then you can use it in your research. Okay. Anything else about this type of kind of data, Mario?
Well, maybe one important thing, but that's really a remark from an academic. If I submit research proposals to organizations who want to fund that proposal,
Yeah.
then what I hear the most is that they always say, look, if you do academic research, you should test your new models on real data, not on artificial data. And you know what? I disagree. I totally disagree. What I think is this. I think that as a researcher, you should, first and foremost, you should test your algorithms on artificial data to try to maximize your understanding in the new techniques.
I understand, yeah.
And once, only once, when you understand how the technique works, then of course you need a validation in the real world, and then empirical data comes in. But from an academic perspective, real data is not so interesting. It's a validation of the results that we obtained on other more artificial projects.
Basically what you're saying, this is rigorous research. You have to start with artificial data, because otherwise you cannot validate it. So first use the artificial data, and then later on do a validation check with real data.
Yeah.
Okay,
great.
great.
You have people who have another opinion, I know that, but to me, if you use real data only, then it's like that you solve case studies rather than general principles that you want to find.
And you also need to, your research has to be, should be done by somebody else to check your research. It's also, I forgot the name, but it should be
applicable. Yeah.
That's the word. Okay. While reading your book, one item really fascinated me, and it's, of course, this has to do with data. In reality, project managers get a lot of data. They swim in it. How to focus. And you describe in one of your chapters what's called control efficiency.
Yeah, indeed.
I really like that chapter. Can you tell what you did and how this helps the project manager?
Yeah, good. Well, the chapter on control efficiency comes after 5 or 6 chapters where I talked mainly about academic research.
Yeah.
And I think I started that chapter somewhere with the words, okay, and is it now also relevant for the real world? Right?
Yes.
That's the question. And if you think about this, then I think that control efficiency is the missing link between academia and research. So let me explain what it is. If you use advanced techniques with data, then of course those techniques work better than if you don't use them. I mean, what can you expect if you're a project manager and you manage your project? Then you have your experience, your intuition, and all those things to make decisions. Now, if you add on top of that data-driven techniques, then you will always do better. I mean, in the worst case, you can ignore them and still rely on your intuition. So my point is, if you use more data-driven techniques, then you will always have better results. And that's what academics want. They want to prove new technique, better results. Yeah. But in reality, it doesn't work like this, of course, because if you use more techniques, it also means you need more data, you need to install more tools to test everything. I mean, there is a cost involved with using more data-driven techniques. And so what I did is the following. Control efficiency is not measuring the improvements of the new techniques, but measuring the improvements of the technique given the certain cost, and we call it effort. So every technique comes with an effort. So what we aim in that control efficiency formula, it's a formula, is we don't want to present better techniques to the real world. We want to present better techniques with the lowest possible effort if you use them. And that is, I think, what's only important for reality. Otherwise, you use very complex machine learning techniques, but it's too time consuming. That's the control efficiency research.
I want to use an example with earned value management. Let's say you get a signal that your schedule has some delays, something like that. It doesn't tell you the cause. It only tells you the effect.
Yeah, indeed.
And then you have to dive in as a project manager with your team. What the hell is happening? Is control efficiency in this case helping the project manager to find the real cause of these delays?
Yeah, let me give my answer based on your example. If you have an EVM system and it reports a delay, then indeed it means there must be somewhere a delay. So you have to dive into the details to find it and hopefully to solve it. And if that system reports delays every week or so, then you're going to spend most of your time trying to find the problems. But we all know that not every signal of a delay is a real problem. Sometimes it's not a big problem, sometimes it is. So it requires a lot of effort if you listen to that system.
Okay.
What we do is we extend that to control efficiency, which basically says, look, we're going to measure when a delay, when a warning signal is really causing a big problem. And only then you have to dive into the details, making you more efficient.
So instead of looking at 100 interesting points, you focus it to, let's say, to one or two.
Yeah, and of course, the challenge is to which one. Which warning signal is important and which one can be ignored.
I found it a fascinating story. So everybody advise, and I'm a practitioner, of course. But you need to have risk analysis up front because I read that this is helping you to do the control efficiency. Is that correct?
Yeah, indeed. Because think about your example again. Suppose that you see a warning signal that you have a delay or so. You drill down to the details and you see somewhere a bunch of activities where you say, okay, they have a delay. Then the question is, okay, so what? What do we have to do? Do we have to take action now, or can we wait, or can we ignore it, or whatever? Well, I think that risk analysis gives you the answer for that. Because if you do a risk analysis upfront, then basically what you try to measure is, if there is a delay there, what is the potential impact of that delay? And if the analysis tells you, okay, it won't have a huge impact on your project, why should you care?
Yeah, of course. Yeah, don't waste your time on that.
Yeah.
Hey, how is this all connected to one of your subjects, analytical project control?
Okay, yeah, that's also an interesting one. It's related to control efficiency. So what I said before is you have the traditional simple earned value methods.
Yeah.
But you have the more advanced statistical project control methods. One is simple but not so good. The other one is very complex but much better. Analytical project control is somewhere walking in the middle of those two. So the whole idea of analytical project control was not to use very advanced algorithms, simple ones. We call it analytical, just simple calculations, just like EVM, but aiming for the same quality than the most advanced tools that we have investigated. So it's trying to make project managers more efficient, low effort, but high results.
Okay. And the funny thing is, I didn't read anything about AI and machine learning because you are using normal statistical algorithms which already exist for 20, 30, maybe 100, well, 100 years, maybe not, but okay, existing for a long time, correct?
True. And that was my ambition. I only spent one chapter on machine learning to show, okay, you can go very far with that, but all the rest is plain statistics.
Okay, because if we are thinking in my company about doing predictive analytics, we are using statistical algorithms in combination with machine learning. And especially if you want to do some predictions, then machine learning can help you. But the old statistical formulas, like exponential smoothing, is just a simple technique, which I did in my student time. So there's basically, okay, let's be aware that machine learning is also a tool, and maybe you can apply it. That's better to tell. Do you agree on that?
Yeah, but I mean, I did some research on the tools in machine learning, and if you get rid of all the fancy terminology, then basically many of those tools are nothing but not statistics.
Yeah, I know. I know. I found that was my same conclusion. By the way, I love to do it. It brought me back to creating code in Python,
Yeah,
which, by the way, was a Dutch invention. Did you know that, Mario?
Python.
Yeah,
No, I didn't know that. No, I
it
use
was
it.
a Dutch brand. Yeah, okay. Mario is from Belgium. I'm from the Netherlands, so now you know the joke. Good. Thank you, Mario. I have another question, which I also find really interesting. It's about reference class forecasting.
Okay.
Now,
Yeah.
you also spent a chapter on that. Please tell us and try to connect it to one of your colleagues, Ben Fleeber,
Yeah.
at Oxford University. Yeah.
If you talk about reference class forecasting, then you talk about Bent, the researcher in that field, of course. But I did my own little contribution in that field because I was a little bit intrigued by the technique. The good thing about reference class forecasting is, first of all, that it doesn't need that much data. I mean, compared to machine learning or Monte Carlo simulations or whatever technique, you don't need that. You just need data from past projects, and that's enough. So it's a pretty simple technique, but also, and that's the good news, it works pretty well. The results, Bent has investigated a lot of projects with that technique. The results are quite good, close to perfect. Now, the way it works in a nutshell is as follows. If you have past projects that are done, finished, then you know, of course, whether you had delays or cost overruns and things like that. Then what you try to do with those past projects, you try to put them in classes. They are called reference classes, based on simple indicators like the size of the project, the type of client, the country, whatever. I mean, different indicators to put project into classes. For each class, we look at the projects of that class, which contains highly similar projects, what, for example, the cost overruns were or the delays for that project. And we can use a simple statistical distribution based on a simple calculation in Excel, and we have it for each class.
Okay. Yeah.
Then, if you are responsible for a new project and you construct your schedule with your best guess estimates, then you look at the indicators of that new project. What is the type of client? What is the expected weather? Whatever it is, and you look to which class that project belongs.
Okay. Yeah.
And if you then see which class that project belongs, then of course you say, okay, if I see a cost overrun of 20% for that project, then I'm going to increase my expectations by 20%. They call that a lift up. I simplify a little bit here. It's a little bit more complex than this, of course, but that's the basic idea. And important to notice that it doesn't require a lot of data, except, of course, past projects, but no advanced tools, no knowledge about advanced statistics. Pretty simple, but you need past data, of course.
If I recall that what Ben Fleeber did is he sent his students to those companies and he collected that data, basically. Yeah? But you need a lot of projects to have all those classes filled. So maybe that's
true.
Yeah.
We did a couple of studies in that field. One in Italy, where we have spent almost 2 years with students, of course, collecting 80 projects in the past from past projects. We also have our own database of projects that they are publicly available, by the way, of already, I think, almost 200 projects with full data that we used to test, does that technique work? And it's pretty impressive that such a simple technique comes close to the accuracy of the more advanced techniques. Pretty impressive.
Yeah. Is the data from Ben Fleeber also publicly available? Do you know that?
I'm not sure, but I'm afraid no. No. Because if it would be available, I would have used it, but I think it's not.
Remembering Ben Fleeber, one of the first academic books I read was his book about his project in Aalborg. You remember that book?
No, not that one. I read papers and it's fascinating. Yeah.
Oh yeah, he's one of my favorite authors. Okay, now I'm going to make a small switch, and I already warned you for that. How can we apply risk analysis and earned value management in a multi-project environment where resources work concurrently in several projects?
Okay, I
Because
was a little bit afraid of that question, but
yeah. But give it a try, because your latest two articles were at least referring to scheduling and that kind of stuff. But give it a try, and maybe we both have to build this bridge.
yeah, it's true. It's true. But it's I expected that question, of course, because I know you're working on multiple projects. But let me give a couple of things that I want to say about this. First of all, I think that first of all, my main research is on single project management. That's what
And
most academics do. There's not a lot of research in multiple projects. So most people or most academics focus on single projects. Now, first of all, I don't think, in a way, I don't think there's a huge difference between the two. What I want to say is, you really have to understand the techniques for single projects before you can even use them for multiple projects.
absolutely, yeah.
That's a fact. But there are differences, and I see two main differences. And based on those differences, I'm going to try to convince you that risk analysis is even more important for multiple projects than for single projects.
Oh, you don't have to convince me. I agree on that.
Well, then next question.
No, that
No.
no, continue. I will wait for my last question for that.
Good. The first difference between single and multiple projects is, of course, that resources are shared, right? Resources jump or walk from one project to the other. And if you share resources between projects, then of course this might cause delays because there are waiting times and those things. I think you call it the flow or something. So that's one reason why we have delays. Now, if you think about this, and that's the publication that you just mentioned that I posted on LinkedIn last week. If you construct, for example, a schedule for a portfolio of projects, then you cannot simply use the algorithms for single projects because of those delays of shared resources. And so I think you have to incorporate those potential expected delays as a kind of a resource buffer between projects. Now, that's not a fancy new idea, I know. But the question, of course, is, okay, how do you size your buffers?
Yeah, absolutely.
Because that's, of course, the challenging question. And
no, it's not only resource buffers, it's also time buffers, I think.
Because
you don't get your resource, you need also a time buffer to overcome that.
Okay. Well, that's what I wanted to say with resource buffers to avoid the delays. So how do you size your buffers? Well, you can use simple rules of thumb that are used most of the time in practice, like 5, 10, 15, or 20%, which does not make sense. Or you can use risk analysis. So I think that risk analysis is particularly important in a multiple project management environment because of those shared resources and because you want to size that resource buffer, that time buffer for the resources in the best possible way. Not too small, because then you have delays, not too large, because then your plan is too big. So that's, I think, one reason.
Okay. You have another one?
I have another one if you want to.
Yeah, please. Continue, because I'm all ears.
Well, the second reason I think, from my perspective, is that, or the second difference between single and multiple project planning is that in a multiple portfolio planning, you won't plan all the little details like you do for a single project plan. If you have 10, 20 projects in your portfolio and you look at all the little details up to the activity level, I mean, it drives you crazy. So I think that for a portfolio, it's better to switch to a kind of a rougher planning. Maybe we can call it a milestone planning, where you put some important milestones here and there. And in between the milestones, okay, details matter less. Now, I think that's, again, quite obvious. I mean, the bigger the project size, the less the details are important. But the question is then again, which milestones? Where do you put the milestones? Most people say, okay, if we have a very important meeting with the client, or if we outsource a part of the project to a subcontractor, that's a milestone. And I understand that. But I think the main reason why you should define milestones is because if you use EVM, then you need details. And if you don't have details in between, your EVM system will not be reliable. You can only really accurately measure the performance at your milestones. Okay. And so my point is, if you want to measure the performance of your milestones, you have to measure where you expect problems. because otherwise you don't see the real status of your project. And that is, again, where risk management comes in. If you can analyze where the potential project problems are the biggest, I think that's a milestone you can use later for project control.
Yeah. Well, I have 5 minutes left, so I try
Time
to
flies.
make a connection. Is that what we do is I had an idea that if you have a lot of work for resources, and let's call them in different roles, mechanical engineer, electrical engineering, that kind of roles, and they work in several projects at the same time. Basically, what we do is what is the level we want them to achieve, coming from the demand of all those projects, and can they achieve that? If not, you have a gap, then you know what will be happening. If they can't achieve the demand, then you will have delays. So we are monitoring it more on a group level than in an individual project level. It gives you a warning about be careful because now you will be confronted with delays. And we found out this can take time before you notice it in your EVM.
Yeah.
So, okay,
I think
yeah.
I think we have to talk after this.
I think we have. Yes. No.
It's an interesting research question.
Yeah. We should meet in something like that.
I guess.
It's always a pleasure to go to Ghent. Okay. You told me once that your research tries to help professionals in their work. How can professionals help you with your work?
I really need them. Honestly, I need them. Even that book is written thanks to the collaboration with professionals. There are even some chapters where I started the research because of a specific demand from professionals. But where can they help me? Well, I think on two things. First of all, please be critical with my research. I mean, I don't mind if you say, this is a shortcoming, because I have to learn from the real world what are the good things, but also what are the weak parts of my research, because I don't want to stay here in my academic tower without any connection with the real world. So criticizing my stuff, I love it. That's why I post my stuff also on LinkedIn. Some people love it, some people don't like it, and I listen more to the people who don't like it than the people who do.
Yeah.
So that's the first thing. Second thing, very simple, data. Help me give me data. I know a lot of people who tell me that they have a lot of data until you ask them to share it with me, and then they say, yeah, but we don't have full data about the project, we don't have a real good schedule, we don't know what the activities are. It's not so easy to obtain data from the real world. But if you have data, I don't know how many people are here listening to this webinar, but if you have data, please send me an email. We can use your data for research.
We had more than 400 subscriptions, so let's invite them to do that. I also promise you that I can help you with data for my clients. Of course, I have to ask permission, but we can anonymize it. That's enough for you. Yeah. Okay. As a closure, and we have prepared this together. Which books do you recommend for reading? And can you see it?
I see that. Yeah.
Okay, so and tell us why you recommend this book.
Yeah, well, I recommended I think 4 or 5 or so. This one is an interesting one. Well, I think it's explained in the title already. A data-driven approach for making rational decisions. What I liked about this book is that we should not forget that using data for projects has only one purpose, and that is to make better decisions. And the word rational is interesting, because I love the book of Daniel Kahneman, for those who know Daniel Kahneman, who explained that we human beings, we are not very rational, and if we make decisions, we are too emotional, we jump to conclusions. Well, that is where data becomes very important, of course, to overcome your biases and overcome your gut feeling, and to hopefully make sure that our decisions that we make are a little bit more rational. And it's a fantastic book. That book tells that story.
And the writer is also an academic?
I don't know the writer. I received the book from someone, and I just read it and I liked it, but I have no clue who he is. I don't know him.
Thank you. Let's go to the second one.
Yeah, this one is a little bit outside my expertise, but I nevertheless liked it because some people say you have the hard skills and the soft skills in project management. And I clearly work on the hard skills with data, and I do not work on the soft skills or the people skills or whatever you call them. And I think we have to stop calling them hard and soft. And I think that I tell that because I have read that book. In that book, he explains that even the human side of project management, let's call them the soft skills for the very last, must be managed by data. Now, this book is not in my expertise, as I said, but what I liked about this book is that we should stop with calling it hard and soft. Data is everywhere, not only in tools and techniques, my field, but also in managing people and their skills and things like that. So that's quite a nice book.
Yeah, this is great. Okay. Let's go fast because Anastasia is telling me we have a lot of questions. Now, we always mentioned this book from Ben Fleeber and Dan Gardner.
This is a famous book and a book that you should read.
I loved it, and I loved it for two reasons. Of course, the reference class, but all the things about biases.
Yeah.
It's amazing. Okay, let's not waste time on it. Read it. Okay. One last book. This is a book I also read from you. I loved it. And especially because you made a business novel. Now, short word, why you took the concept of the business novel?
Because what I learned from experience, from teaching to professionals, is that if you only tell them the techniques and the tools and the formulas and the statistics, they don't want to hear it. If you tell the story, how you implement those techniques and what the difficulties are if you implement them, then they understand much better how they work. And based on years of experience in trying to convince real project managers to implement data-driven techniques, I thought, okay, I'm going to tell that story. And that's the book.
Excellent. Last book is the book we are discussing. Why do I show this? Because it has a QR code which gives you the possibility to have a really interesting summary of your book with all the chapters. So, Mario, we have a lot of questions, Anastasia told me. Thank you for this discussion, interview, whatever you call it. I really loved it. And Anastasia, can you come up with the first question? And I have to switch off this one because I don't need that. Can you read it?
Do you see the perspective of machine learning methods applied to scheduling multiple projects? Yeah. So I think that the question here is, what do you think about machine learning, and can it be used or will it be used in the future for single and multiple projects? Well, honestly, I don't know, but I have no doubts that it will not disappear. That whole machine learning thing and that whole advanced algorithms and artificial intelligence will become more and more popular. I do not doubt about this. But I think we have to be careful. As I said 10 minutes ago, machine learning often is nothing more than statistics in a nice, bigger story, and that's it. So, yes, I think they will be used, but let me give you a warning to everybody. You first have to understand what your problems are before you switch to those advanced methodologies. And maybe it's good if you want to implement a more data-driven project management methodology in your company. Maybe it's good to work in baby steps. Why not starting with something easy and then a little bit more statistics and then a little bit more data? And if you see that what you do is working for you, then maybe the step to machine learning is just a step to more advanced algorithms, and that's enough. So, short answer, yes, I think it will become popular, or it will certainly not disappear, but a warning, certainly a warning.
Let's de-hype a little bit.
Yeah, a little bit. Yeah, why not?
Thank you. Anastasia, the next question, please. When you analyze data, how do you even know if it is from a well-done project or a poorly done project? Oh, this is an interesting question.
Yeah, do things like cost overruns and delays really tell the story?
Yeah.
Well, yeah, of course not. I mean, there is so much more than only being on time and within the cost. I totally agree with that. I totally accept that. And I totally am aware that what I do is only a small view on the bigger picture of project management. There are many more, other factors important, but I have to be honest. What I do in my research focuses very much on that time, cost, and quality, and not on other things like, for example, how well your project is accepted by the client, what the impact is of that project on society, and many more factors that, of course, are important, but I do not take them into account. Which does not mean that you can't. I mean, that's just me. I think that even for these things, you could use a more data-driven methodology, but not much research is available for that. So, it's not a complete answer, I guess, but it's the honest truth.
Okay, Anastasia told me that we have 30 questions left, so I have a proposal. We continue till the end of the webinar, and we will give a try for the other questions to answer this on LinkedIn. Okay, let's continue. Anastasia, please. So keep on asking your questions. Okay, control assumes effective interventions. What are the necessary and sufficient interventions needed to keep your projects on track? Yeah, good question.
A good question.
I have some ideas, but I leave it up to you, Mario.
It's a pretty challenging one, but I think that the answer is a quite simple one, and maybe not the answer that people expect, but that depends very much on so many factors that I do not control. What I do in my research is telling you whether there is a delay or whether there's a cost overrun. I also tell you whether you have to trust that signal or not. I also tell you what data do you need to really know how to find the problem, but how you solve the problem, because that's basically the question here. That depends on so many factors. It depends on your own style of managing the project. It depends on the budgets that you have available. It depends on your client and so many other things. What we do in is, sorry.
Also the priority within your portfolio, all kind of things. Yeah. Are you allowed to steal resources from other projects, etc., etc.? Yeah, that's a lot of possibilities. I think those
are the things that we test in our research: is sharing resources or shifting one resource to another and so on. But yeah, it depends, of course, on that specific project what you should do.
Yeah. Okay. Thank you. Next one, Anastasia. Shouldn't we know by now that multitasking costs more time? Why does it still happen? Yeah, this is a practitioner question, of course.
Yes, but I think I have a very simple answer on that, because it's in our nature. We did some research with students, let them work on a multitasking environment or let them focus on one task, and we indeed saw that multitasking causes delays and so on. And we had that discussion with students. Why do you do it? And I still do it too. I think it's in our nature, but I think we have to avoid it as much as we can. What we also saw, by the way, is that multitasking is not always bad. If you work long enough, then sometimes learning, because that's also in our nature, if we do something, we learn and we become more efficient. Well, we learn better if we do multitasking. But there is a price to pay, and the price that you pay is that it causes, certainly in the beginning, delays and probably also cost overruns.
We always distinguish between good multitasking and bad multitasking, and that's not an easy one. Okay, yeah, I agree. Next one, please. Is artificial data, yeah, some sort of digital twin of the project? Oh, interesting.
I like the style of that question. It's a kind of a digital twin of the project. Yeah. What it mainly is the following. If we create artificial data, then we create so many projects, very diverse in terms of structure, in terms of resource use and whatever, so that we are 100% convinced that if we go out there and we find a real project, it's in our data set. So it's not only a twin. It's more like you have that project in reality, and then we create 10,000 twins of that project that are all a little bit different, so that we are sure that go to another company and we have that project in our database too. So it's more than a twin, it's bigger, but I should have called this in my book.
It's also an efficient way of creating artificial data, I think.
Yeah.
Yeah.
Sorry?
It's also an efficient way of creating artificial data.
Yeah, well, but that's of course what we do. If we generate data, then of course the inspiration comes from the real world. Yeah, of course. But then we multiply it in different versions.
Okay, great. Next one, Anastasia. We still have 6 minutes left. I'm curious to know how you tackle project scope management before making the schedule. Yes.
Yeah, that's an interesting one. That's a challenging one. And that's a question that I really like because I told you I'm not only an academic, I also have my own consultancy company. And of course, what I mainly do in my consultancy is trying to help companies to make a schedule and risk analysis and project control. But sometimes I have to help them also by trying to define the scope of the project. Now, I have not done any research about this, I have to be honest. But what helps me, and I think, Jan Willem, you said that also, what helps me is to look at the network, to try to draw a network of logical relations between potential activities, because not everybody is like this, but I know that Jan Willem is like this too. If I don't see it, I don't understand it.
Yeah.
And if I see it in a visual picture, then I see what is lacking and what do we have to change. And I don't know where you can call that scope management, but at least it helps you to better define what you have to do to reach your goal of that project.
And you have to do it with your team. It's
Yeah,
excellent sessions. It's
of
really,
course.
it's envisioning your project.
Yeah,
And I always say, start with the end.
yeah.
Start,
Start
yeah.
with the goal and try to reach the goal.
Yeah, absolutely. Okay. Next one, Anastasia. Is there a perfect formula for combining human intelligence and intuition and data-driven decisions? Yeah.
Yeah, I think there is one, honestly. I truly believe in that, but I might be a little bit biased. So you have human intelligence, maybe we have to sometimes call it human stupidity sometimes, or human biases, and then you have data-driven methodologies. So the question is, I guess, how do you combine them? Well,
Yeah.
I think you have to combine them in the following way. That's what I always say to my students. First the data, then the human intuition. What you have to do first, I truly believe that, is using techniques, methodologies with data that give you a solution for the problem.
Yeah.
And then use your own intuition and experience to look at that solution and maybe not accept it if you don't like it. But at least then you have a good solution without any feelings or biases in it. The only problem that can be in that solution is that the data was not good enough. Garbage in, garbage out, right? But at least you have a better understanding of the problem. And then, of course, you have to use your intuition and experience to finally make a decision. So my formula is this: first data, then human intelligence.
What my business partner Albert Ponstein did with his PhD research, he connected human intelligence with a data-driven priority list. And he said, can we use human intelligence in a created list from data-driven? And he proved that can be very successful. You can improve even your data-driven decisions. Yes, it was a very interesting research. Anastasia, he's not there, Albert. He's on holiday. So, Anastasia, please. Yeah, Mario. This is one for me. I want to have this as the latest one. Will this be your latest book? Because you're still a young guy.
I have a very clear answer on that. Of course, I will never write any book again anymore, but I know I'm lying. I know that right now, I don't even think about writing a book because writing a book is a hell sometimes, but I know that within a few weeks, I'm going to feel that urge again to start writing. I'm sure about this. There's so much more to tell. But for now, yes, this is my last one.
Okay. Now, what I like that you please continue with sharing your knowledge and experience with us via academic papers or maybe a new book.
Or a new webinar.
Or webinar, yeah, continue doing that. We have this role of the webinars. The next one will be in Agile, so Jira connected to Epic Flow. But how can you do it in the Agile world, which is slightly different from the waterfall world? But Mario, thank you very much. This was so fast this hour. Maybe it was a emotional record, so fast, but it was.
Time flies when you're having fun, eh?
Yeah, as always. So let's keep on building the bridge, and we will be willing to help you with creating data, and maybe let's try to find another way of doing earned value management on a multi-project environment. I have some ideas about it.
Good.
Thank you, audience. Thank you for your questions. We will do our best on LinkedIn to answer the questions which were not phrased yet, and I'm looking forward for you to see you in the next webinar. Mario?
Thank you very much, Jan Willem. Thank you very much, everybody.